Hello class, let's take a look at example 3. So this is what they're saying on example 3, and basically they want us to create a probability distribution using the following values, and then we have to assume that you have a binomial experiment. So technically assume we have a binomial experiment. Now, the first portion is within the binomial distribution, they want you to create a probability distribution. So technically, x has to be defined. In this case, it'll be a random variable. And the idea for your x's is that, well, if n is equal to 4, then you're going to have successes within 0, 1, 2, 3, and technically 4. Now, the next portion is to technically evaluate the binomial formula, in this case, this messy formula, for the number of successes 0, 1, 2, 3, and technically you stop at n. N will be the value of 4. So to complete this table, all we have to do is technically run the actual proper code, and then please check if you're matching with our solutions. So to run the first one, you're going to be activating from the distribution the actual binomial PDF with the following parameters. So technically n is equal to 4, so it'll be 4, comma, the probability of success is given as 0.20, so 0.20, and then for the very first one, 0 is basically one of the evaluations, so that represents p of x is equal to 0. Please evaluate and see if you're matching. I'm obtaining on this one 0.4096. Next, to complete this one, we technically have to run it again, but then now modify the number of successes. So in this case, for the next one, we're just going to change it to 1. Please check if you're matching. I'm running the code again, but I'm modifying the successes, changing them from 0 to technically 1. See if you obtain 0.4096 as well. And then we're going to be doing this iteration over and over until we actually reach the value of 4. So the next one will be 2 successes. 2 successes, I'm getting 0.1536. 3 successes, please run it again. I'm just going to change 2 to technically 3. And I'm getting 0.0256. And then the last one, since we technically have well, a total of n is equal to 4, the more successes that you can have is actually 4. So in this case, evaluating 4, we're getting 0.0016. Please double check that you're matching with each one of the actual outputs. And let me actually display most of them in here because, well, you're creating a probability distribution. Remember that in the probability distribution, you only have your x's. All of these will be evaluated. We will be evaluated with the PDF, since you're just looking at, well, 0, 1, 2, 3, and 4 successes. In this case, 4 successes for the problem.